is there for JEE. It was today's lecture for Saturday yesterday. So we on Saturday's lecture we are dealing with the series part. So series part में last class till what where did we see in the series part last class? Some of us some basic formulas of the we got acquainted with the summation symbol, the various properties of the summation symbol, how the properties will be there, summation of constant, summation of n plus c, that constant will become, so these are different summation of n plus c and summation of n bracket and then c different. These various properties of summation were there, and we did some standard formulas, the summation of some special series. The special series included sum of first n natural numbers, first and odd numbers. Okay, Afrin, this is for the G class. Today it is for the G class. Summation of first and odd numbers. After that, first and even, and squares of first and natural numbers and cubes of first and natural numbers. Okay. Now, after that, we were dealing with some questions over these terms. So let's deal with these questions. So let's say evaluate the sum of the series of the sequence up to n terms where an is given by n plus 1 into n plus 2. I will just get in terms of finding the general formula. Let's say find a sum up to 10 terms. There. If you're getting the answer, write the answer in the chat box, and if you're not getting, write EXP in the chat box. Okay, Afrin? If you get stuck with the answer, write EXP in the chat box.
So is it 570?
Yes, correct. But you have taken a lot of much time for this question. It should not take so much time. See, how do we do? We have to find out, sir, Sn. S10, sum of first and terms is A1 plus 8 and so on up to A10. So this is what? So A1 to A10, nth term is given by n plus 1. Here, I write, sir, summation of nth term. Nth term where n varies from 1 to 10. This is only the things of A1, A2, A4 up to A10.
Screen is lagging.
Yes, sorry.
Screen is lagging.
Screen is lagging means definitely the problem is from your side, because video problem does not never occurs. Once you disconnect, okay, once you disconnect and log in, maybe then the problem will get resolved. Because if the video,
Try rejoining again.
yeah, okay, video problem never occurs. N plus 1 into n plus 2 and n varies from 1 to 10. So this will be equal to the summation of, what is this complete expansion, n square plus 3n plus 2, n equal to 1 to 10. And this, now this is equal to the summation of n square separate summation of 3n separate summation of 2. N equal to, so 1 to 10, only then you can write this formula, n into n plus 1 into 2n plus 1 upon 6. Summation of 3n, so 3 will come out common. Summation of n is sum of first n natural numbers, n into n plus 1 upon 2, and this is 2 multiplied by 10. When we have substituted 10 everywhere. Yes or no?
Sir, could you please scroll down?
Okay, 3 into 10 into 11 upon 2 plus 20. Calculate this answer, it turns out to be equal to 570. Got it, Dhananjay Pujita? Yeah, friend, take the screenshot quickly.
Yes, sir. Okay.
Okay. Now, here in these questions, I have given you the nth term directly as a formula of n. If suppose nth term, if nth term of the sequence is given as a formula of n, then the answer is very easy to calculate. But if the nth term is not given as a formula, then your target becomes to find nth term as a formula. After that, you can calculate the sum, that is summation. So let's say now if I give you evaluate. One into two into three plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on and so on and so on up to where? Up to, let's say, 15 terms. How to start? Can you tell me? Don't tell me the final answer, just tell me how to start. Unmute yourself and tell me. Anybody? Yes, the process.
Sir, first we should multiply the given terms, sir. Then we have to convert into the formula and we have to do, I think, sir.
No, if you convert, you have to, if you do the actual multiplication. So first term will be 6, second term will be 6 for the 24. The next term will be, means here. If you're doing the actual multiplication, this is 6, this is 3 to the 6, 4s are 24, 12 5s are 60. Next term will be 4 into 5 into 6, 4 5s are 20, 26s are 120. If I just give you these random numbers, suppose if I hadn't given you the above multiplication process, this question I would have given you. Evaluate the sum of the sequence 6, 24, 60, 12, next number, so on. Then how can you convert these random numbers into formula? Means definitely will face the question, sir, this 6, 24, 60, 20, how are you generating those numbers? What is going on inside my head? How can you calculate? How can you predict what next number I will write? The next number I can write 121 also. The next number I can write 200 also. Or the next number I can write 300 also. So just by observing these four numbers, you can never predict what next number sir will write. Yes or no? What is
Yes,
going
sir.
on? What is going on inside my mind? You can never know. That's why if I give you these 624, 6020, the question is almost impossible to solve. So I have made it easier for you. So how, means you should ask me a counter question. So how are you generating these numbers? What is the relation in between them? So the relation between them is this. How those numbers are generated? They are generated in this way. And now you're talking in the reverse manner. That sir, Pujita is saying, sir, first I will multiply, means the known pattern, the known mapping that I have given you, I will make it unknown, and then I will try to form the formula. So this is just going the long cut way, and that is the incorrect. Any other approach, doing the actual multiplication is not needed here. Dhananjay, how to start? Afrin. Okay, see. Here also you have to find this complete is my A1.
We could add all the terms.
Yes, or add all the terms. How in the, that is the question. We have to add all the terms, but how will you add them? That is what I'm asking. That is the question. You have to add all the terms. A1 plus A2 plus A3 and so on. You have to find out the answer. So see now. If you can find out A1 as a formula of an A2, A3, A4, or let's say AN, here somewhere AN will be there. AN is a formula of N. Yes. Suppose example, just hypothetical example I'm giving. Let's say suppose hypothetically AN turns out to be by some magic. You find out that AN is equals to some mapping of N, let's say N square minus 3N plus 7. Hypothetical example. So if you are able to find such formulas, sir, you substitute n equal to 1, I will get this particular value. This particular value is 6. You substitute n equal to 2, I will get this particular value, that is 24. If you substitute n equal to 3, I will get this particular value, that is 5 4 23 60. If you get able to find this formula by some magic, then the question reduces to the previous type only, summation of this formula and then just summation of square, summation of natural numbers, summation of constant, and so on. So now our target reduces to, can you find an equal to as a mapping of n? So observe here that an is equals to the first term. These all the terms are nothing but product of three natural numbers, three consecutive natural numbers. And how are three consecutive natural numbers represented? The three consecutive natural numbers are represented by sir n multiplied by n plus 1 multiplied by n plus 2. Okay, so this is my an, but you have to make sure that when you substitute n equal to 1, The series actually starts from 1 into 2 into 3. Yes, it starts. When you substitute n equal to 2, the series actually starts from 2 into 3 into 4 and so on. Got it? So now since an is equals to n into n plus 1 into n plus 2, so what our target is? Sir, you are asking S15. That means you are asking A1 plus A2 up to A15, which is nothing but an summation n is equals to 1 to 15, which turns out to be equal to, sir, n into n plus 1 into n plus 2, n is equals to 1 to 15. How do we do this product? Expand. This turns out to be n cube plus 3n square plus 2n. And then separate the summations and then use the formula. Summation of cubes of natural numbers also, you know, summation of squares also we have the formula, summation of natural numbers also we have the formula. For the process you can do the previous formulas that we did. Okay.
Yes, sir.
And the last step we have to substitute n equal to 50. Okay. Now next question.
And scroll down, sir.
Got it? Okay, let's move ahead
Yes, sir.
now.
Done, sir.
Now next pattern, if I give you, let's say evaluate,
Sir, could you please scroll down?
take the screenshot quickly.
Done.
Evaluate three into 5 plus 6 into wait 1 minute, not 3 into 5 plus, let's say, 5 into 7 plus 7 into 9 plus 9 into 11 plus so on and so on up to, let's say, 10 terms. 10. If you know how to start, I don't want the final answers. I want I'm interested in how to start. I'm interested in how the process. So if you get, yes sir, I got the process how to start, then tell me. Unmute yourself and you can answer. How an will be there? We will do this question only up to this an formula. An is equals to, if you are able to write this mapping, then the further part you can do by yourself. Just tell me what this an mapping will be there. Okay, Pujita is answering n into n plus 2. Yes, that was the answer I was expecting, but it's a wrong answer. Now, many students here have the delusion that's a C. Now, these are all the numbers in each and every term. The numbers which are present, they differ by 2. So, if they're differing by 2, how are two natural numbers that differ by a difference of 2 written? So, they are written as n multiplied by n plus 2. So I can take it to be equal to an. No, there are two problems in this thing. What is the first problem? The first problem is if you substitute n equal to 1, this n equal to 1 does not give me, sir, 1 in, it will give me 1 into 3. It does not give me 3 into 5. N equal to 2, it does not give me, it will give me 2 into 4, not the second term. So nth term equal to n into n plus 2, that we cannot write. Okay, so let's not substitute n equal to 1. We will substitute n equal to 3. Then the problem will be resolved. Means the question that you are saying, sir, that problem can be resolved. So substitute n equal to 3. 3 multiplied by 5, and then we can go on. Okay, that you could do. That's a
Odd
summation. A summation of
starts with 3.
1 minute. 1 minute. Summation of the first 10 terms you're asking. So we can say that n multiplied by n plus 2, and n varies from 3 to 10. Is that question you may think. I'm not saying that this is the answer. I'm thinking that this you may think that's a n into n plus 2, and they take summation from n to 3 to 10. So n equal to 3, the first term will be managed, but these 3 to 10, these are not, number of terms are not 10 terms. So okay, so if number of terms are not 10 terms, you take 3 to 12. Now there are 3 to 12, there are number of terms are 10. Take
So, but
note.
we have to calculate only the odd numbers.
Yeah, yes. Now
3,
that
5,
is, yes,
7, 9.
yes. If you substitute n equal to 3, this is counted for. Okay, if you substitute n equal to 4, 4 into 6 comes into play, and that is not required in a summation. If you put n equal to 5, this is counted for. If you substitute n equal to 6, okay, fine, but that is not required. So that is another problem. So this way is not the correct answer. Okay, and another problem, always make sure to start this sequence from n equal to 1 only, because the formulas that we have, it is summation of first and natural numbers, squares of first and odd squares of natural number, cubes of natural numbers, first consecutive. 7 square plus 10 square, 7 square, 8 square, 9 square, 10 square, so on. That's, we don't have a standard formula. Okay, so what we will do here, we will do, excuse me, observe these first terms, first numbers in each of, sorry, just observe these numbers: 3, 5, 7, 9, and so on. If I just take those numbers, 3, 5, sorry, 3, 5, 7, 9, and so on, can you observe that this is an arithmetic progression? And if this is an arithmetic progression, a is equals to 3, common difference is equals to 2. Common difference is equals to 2. So nth term of this arithmetic progression, okay, this, or let's make it tn, dot tn. So nth term tn of this arithmetic progression is given by first term plus n minus 1 into d, that is 2. So nth term is given by 2n plus 1. So now if you have these nth terms, there is 3, 5, 7, 9, 11. And here when you n, and here make sure, take note that n always varies from n equal to 1, 2, 3, 4, 5, 6, t1, t2, t3, t4, n equal to 1, 2, 3, 4, 5, 6. Now you don't have to worry about n being odd or n being even. And takes now all the values consecutively. So now n equal to 1, you get the 3, n equal to 2, even number, you get 5, n equal to 3, 7, n equal to 4, even number 9. So now can you say this nth term of this sequence is equals to, so first term nth term of this sequence is, so whatever is the first term, addition to whatever is the first term. What is the first term? 2n plus 1. What is the next number in that product? First number plus 2. First number is 2n plus 1 plus 2. So 2n plus 3. Now check. If you substitute n equal to 1, so this is an odd number, 3. 3 plus 2, that is 5. If you substitute n equal to 2, 2 2s are 4 plus 1, 5. 2 2s are 4 plus 1, 5. Why are we getting? Because we found the nth term of this geometric progression is 5 into 7. Substitute n equal to 3. 3 to the 6 plus 1, 7. You properly got 7. 7 into 9. So now up to summation of up to 10 terms, it's just summation of n equal to 1 to 10. Write everyone quickly. Okay. 2n plus 1, 2n plus 3, n equal to 1 to 10, and this we have the formula. N equal to 1 to 10. Got it? Now you can calculate. Now can I leave the further part for you to calculate? Okay. Take the screenshots right quickly.
Answer.
Afrin Dhananjay. Done.
Yes.
Moving ahead.
1 minute, sir, please. 1 minute, 1 minute.
Just tell me the formula for the nth term. Evaluate.
So the first term of each of these terms,
The
8,
first,
20, they are in AP, sir. A is
yeah.
equal to 8, D is equal to 5, sir.
No, tell me the final answer. Nth term of this sequence. How to write the nth term matrix? Okay. So see now, this will be 8, 13, 18, 23. This is forming an arithmetic progression. Yes or no? 8, 13, 18, 23, and let's say Tn of this AP purple sequence. I'm writing the nth term as Tn. So Tn is equals to, and the nth term of the original sequence, the original multiplication sequence, the nth term I'm representing by A1, A2, and so on. And there I'm writing the nth term as An. So now T1, now for the purple sequence, can I write Tn equal to first term, that is A, plus n minus 1 into common difference. Common difference is 5. The purple sequence is an arithmetic progression. So is it 5n plus 3? Do everybody agree with me? And if this 8, 13, so first term is 8 plus 5, 13 plus 5, 18 plus 5, 23 plus 5 plus 5 plus 5. So common difference is D. So A plus n minus 1D, 5n minus 3, 5n minus 5 plus it, minus 5 plus it plus 3. So this is the nth, means this is the first number of every this product sequence. So an will be equal to what, sir? Nth term is the first number of that. What is the first number? That is 5n plus 3. And in that first number we have to add 3. So if in that first number, if you add 3, get 5n plus 6. This is the nth term of the original sequence. And once you get this, can you find the summation now?
Yes, sir.
Okay. Evaluate. One plus 2 plus 1 plus 2 plus 3 plus 1, 2, 3, 4 addition 1, 2, 3, 4, 5, and more are there, plus 1 plus dot 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 dot, dot up to, now see what I'm writing here. You understood how the sequence is being formed? 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, then 1, 2, 3, 4, 5, then 1, 2, 3. Now see what I'm writing. I'm not, okay, if I give you, let's say this is, let's say up to 100 terms if I give you. So don't be under the impression that this will go to like something like 1 plus 2 plus 3 plus 4 plus 5, and so last it will go 1, 2, 3, 4, 5, 6, 7, and up to 100. Or maybe last it will go up to, see the first, if I give you for one term only, it comes up to 1. If I give you 2 terms only, it goes up to 1 plus 2. If I go up to 3 terms only, 1 plus 2 plus 3.
Sir, excuse me,
Yes, tell me, Afreen.
sir, will it not come as 1 into 1 plus 2 into 1 plus 2 plus 3 into 1 plus 2 plus 3 plus 4 into, like, will it not come as
No, it will not come into. Why are you going into multiplication?
okay, sir.
No role of multiplication here. 100 terms. See, 100 terms, the last, it will not be up to 1 plus 2 plus 3 plus 4 up to 100. Because if I just give you 4 terms, let's say if I just give you 5 terms, for suppose. So 5 terms are what? This is my first, second, third, fourth, fifth. Got it? So if I just give you 5 terms, that is not even a proper, groups are even not completed. Some groups are completed properly and some groups are incomplete. So I will initially I will give you an easy question. Easy question what? The easy question is, I have given you each of the terms in brackets. Each of these are groups and I am giving you up to 100 groups. Okay. Now the question is easy. Yes or no? Proper 100 groups I am giving you. Calculate, evaluate the sum up to 100 groups. Don't tell me the final answer, just tell me I'm interested in the mapping. Mapping, if you get, that will be the answer. If you get the mapping, then let me know. Not the final numerical value. Okay, just the mapping value. Okay, 1 second, Pujita.
So an is equal to an minus 1 plus n, sir.
An minus 1 plus n. But
Yes.
this way you okay, an minus 1 plus n. Yeah, yes, that is correct.
A
But
99 plus 1, sir.
yes, so if you cannot calculate the sum using this formula.
Yes.
Because what you will do, so you will see that solution is what Dhananjay is saying is the nth term is the previous term, and in the previous term we are just adding the n. So this is 100% correct. Like how you are obtaining the third term. The third term you are obtaining as a previous term, that is 1 plus 2 is already present. So just add the third term 3 over there. So this is correct. But for calculation of this formula, you need the sum of up to 100 groups, that is S100, A1 plus A2 plus A3. If you are able to find such mapping, that only in terms of n, not an or an minus 1, then you can use this summation of n square, summation of natural numbers constant. But how to calculate this? So if you're telling, so for an I will require an minus 1. For an minus 1 I will require the previous. For that an minus 2 I will require the more previous. So this is a, even though a correct result, but it is not a useful result. So see here that, can I write here that nth term? Can you see that it is nothing but 1 plus 2 plus 3 plus dot 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 dot. Be careful that sometimes the last term minus 1. Here luckily for us the last term is coming out to be n. So there is that we can avoid. Sometimes that last term comes out to be n minus 1. Here the last term is n only. Nth term, can you agree that if this is a3, the a3 is 1 plus 2 plus 3, this is a4, a4 is 1 2 3 4, a5 is 1 2 3 4 5. So nth term an will be 1 plus 2 plus 3 plus 4 plus 5 n. And this sum I already know. This summation I already know. This is what is the summation? N into n plus 1 upon 2. Finish. The question is over. Nth term you got as a mapping. N into n plus 1 upon 2. These mappings that we are finding out. Got it?
Yes, sir.
Okay. So S100 will be equal to summation of n equal to 1 to 100 is equals to summation of n into n plus 1 upon 2 from 1 to 100. Take 2 completely outside and then you do the summation n into n plus 1 equal to 1 to 100. And here you can proceed as previous. Okay. Done? Now next.
1 minute, sir.
Write quickly. Okay. Next. Question number 6. Evaluate one square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus this is NCRT question. Exercise 9.4. Just 1 second. Try for 1 minute. Okay. similar to previous question only.
Sir, then an equals to 1 square plus 2 square plus 3 square and so on plus n square, sir.
Yes, correct.
Sir, n into n plus 1 into 2n plus 3 whole divided by 6, sir.
2n plus 1 complete upon 6.
Yes, sir.
Yes. So it will be, sir, an. An is 1 square plus 2 square plus 3 square and so on up to n square. Okay. So this comes out to be equal to n into n plus 1 into 2n plus 1 upon 6. And this is the formula. Once we get the formula as a mapping, so how to the final answer, the summation will be, sir, an summation of means s 100 if you have 100 groups. Okay, 100 groups. So here it will be, so this is a1, this complete thing is my a2, this complete thing is my a3. Summation up to 100 terms and 100 groups, these are different thing. If I give you 100 groups, then the question is easy. Proper groups are being formed. 100 terms, then some groups will be formed properly, completely. Last trailing, last it will be something will be incomplete. Okay, so that will be a difficult question to solve. It's not impossible, but okay. So then summation of this will summation of an n equal to 1 to 100. And how will you calculate? This is equal to summation of n plus 1 2n plus 1 upon 6 n equal to 1 to 100. So this becomes a 1 upon 6 completely outside. Summation of n 1 to 100, and then we'll expand this 2n cube plus 3n square plus n. And then by splitting, you can calculate the summation. Summation of cubes, summation of first n natural number, first n from because from 1 to 100. Cubes of first n natural numbers, that formula you have. What is the formula? So you have to simply take the summation of natural numbers and their complete square. That is 1 plus 2 plus 3 plus 4 100. Its complete square. Summation of n square also formula, you know, summation of n formula also, you know. You can calculate. Okay. Next. Last question for today. Evaluate. One plus 1 plus 3 plus 1 plus 3 plus 5 plus 1357 plus 13 dot up to 100 terms, not groups. This is a little bit different. Now here there are no groups. Okay, I'm not telling you groups. Are you getting, students? Dhananjay, Pujita, Afreen. Are you getting how to solve?
Explain, sir.
Okay, see. 100 terms, so you know, you must be up to now. If first of all, this idea should be clear. If I'm telling 100 terms, so these groups which are there, whatever the last term will be there, properly all the groups completely they will be formed. All the groups will be completed. It's not a necessary thing. Means 1 3 and 1 3 5 and 1 3 5 7. Lastly, it will be, sir, 1 3 5 7 9 only up to 100 terms. This is not a guarantee. It may happen that, sir, in 100 terms, let's say instead of 100, if I have given you, let's say 7 terms only, then you can see that first 1 2 3 4 5 6 7 means what? So 3 groups were were properly completed, and the 4th one was still incomplete. It was still a running one. So in 100 terms also that may happen. Right now we don't know. So first of all, we will evaluate the summation. We will see, sir, how many groups are formed completely, and in the last one, how many terms are left. So, sir, to calculate up to 100 terms, number of terms in each group. Okay, number of terms in each group. Number of terms in each group. So first group, how many terms are there? Number of terms is 1. In the second group, number of terms is 2. In the third group, 3 terms. In the fourth group, 4 terms, and so on and so on and so on. So means if I concluded my sequence, the original sequence, if I concluded it, if I terminated it at fourth group, means the number of terms in the sequence I have taken is 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. Okay, so 4 groups completed means 10 terms, or you may say 10 terms completed means 4 groups. So if I want 100 terms, so 100 terms if I want means what do I want? In this 1 plus 2 plus 3 plus 4 plus 5, this is the number of terms. Okay, this is the number, this addition of this is the number of terms. So what do I want? Actually, I want 1, that is 1 term, and more 2 terms, then third group will contribute 3 terms, fourth group will contribute 4 terms, and so on. This addition should be less than or equal to 100. Got it? Let's say nth group is contributing the n terms. Nth group is contributing n terms. This addition should be less than or equal to 100. If there is a particular n for which this addition becomes proper exactly equal to 100, then we will say that so that n proper, all the groups are completed. So if you just see 1 plus 2 plus 3 plus 4 up to n, what is the addition? So this addition turns out to be equal to n into n plus 1 upon 2. Yes or no? And this addition should be less than or equal to 100. Implies n into n plus 1. This should be less than or equal to 200. Now you can solve this quadratic inequality by the usual method also. In quadratics, you have done these questions in brief. There you can do complete by the standard method. The inequality, you remember, this is n square plus n, the standard method. N square plus n minus 200 should be less than or equal to 0. So this is a graph will be something upwards, facing upwards with two different roots. So the n should lie between this value. The interval that we are looking for is a positive. The graph is something like that. This is the required interval that we have seen. But here no need to go in that much detail. It's a simple, it's a smaller value. 200 is a very small number. So you can just go by trial and error also. Two consecutive products, two consecutive natural numbers. So you can see n is equals to 30. Simply by trial and error you can go. If the number is bigger, some random number, then the quadratic standard method also I have told you. So just by trial and error, n is equals to 13. So if n is equals to 13, means what? So 13 groups will be complete. 13 groups will be formed in a complete manner. 13 groups will be formed completely, and the 14th group, some terms will be left. Only some terms will occur. So 1, 2, 3, 4, up to 13. Number of terms from each group. Number of terms from each group. 13 groups completed. Okay. And 14th group incomplete. So incomplete means up to what extent? So let's say, means suppose 1, 2, 3, 4, 5, 6, 7 up to 13th group. 13th group, if suppose they contribute 98 terms, then the 14th group I will take just only 2 terms I will take from the 14th group. If this contribute 90 terms, then the 14th group I will take 10 terms. Okay. So 1, 2, 3, 4, 5, 6 up to 13. How many terms they are contributing? They are contributing 1 plus 2 plus 3 up to addition 13 total terms. These many terms they are contributing. So that is 13 into next number upon 2. 1 plus 2 plus 3 up to n. 13 into 13 plus 1 upon 2. So this is 13 into 7. 13 into 7 is 91. So 91 terms are contributed in the completed groups. And the incomplete group is the 14th group. So 9 terms. Actually 14th group total number of terms are 14. 14th group total number of terms 14. But we are interested, we will take only the first 9 and we will terminate a sequence. Got it? So now I will write here. Now finally I will write the sequence as, this is 1, 3, 5, 7, the odd numbers only. No? So here now I will write the sequence as, so 1, then 1 plus 3. After that 1 plus 3 plus 5. Then so on and so on and so on. This is first group completed, second group completed, third group completed. Okay. So group 1, group 2, group 3 up to group 13. Okay. Group 13 will be what? 1 plus 3 plus 5 plus. Please don't make the mistake that it will be up to 13. It is not 1, 3, 5, 7 up to 13. In the group 13, number of terms are 13. Number of terms means number of odd numbers are 13. So last term cannot be 13. Last term will be something different only. Okay. So whatever it is, we are not interested in the last term of this, last odd number of this. Yeah, we got the third. There are 13 odd numbers. That's okay. And lastly, in the group 14, that we have, how much we are taking? We are taking only 9 terms, not up to 9. 1, 3, 5, 7, 9. Don't conclude over 9 here. That is, we are not terminating at 9. We are taking 9 terms. So plus dot 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 dot. I am not interested where that sequence will terminate. Don't waste time unnecessarily over finding the last term. It's not needed. We are interested. It is just given that if there are 9 terms. That's it. So this last incomplete group summation. So sum of first and odd number, first consecutive odd numbers, and total consecutive odd numbers that he has ready-made given you 9 terms. So can I write 9 square over here? This summation. First and odd numbers is n square, no? So 9 terms, 9 square. Simple. And now G1 plus G2 plus G3 plus G2 plus G3, complete groups are formed. Complete groups are formed. That reduces to the questions that we solved previously. This. Okay. So these groups are something like G1 plus G2 plus G3. So Gn. What is Gn? Gn. So in nth group, there are n odd numbers and summation of first n odd numbers. First n odd numbers is equals to n square. Yes or no? So this is actually
Yes,
summation of n square. That is summation of Gn, and varies from 1 to 30. I want G1 plus G2 plus G3. G1 plus G2 plus G3 up to G13 is this value. So my final answer would be summation of n square from n equal to 1 to 13, and then summation and separately 9 square. This is a separate, and this 9 square is separate. So summation of n square, square of natural numbers from 1 to 13 is what? N into n plus 1 into 2n plus 1, that is 27 upon 6 squares of natural numbers. And this 9 square, 81 is added separately. Whatever this value is there, that will be our answer. Got it?
Yes, sir.
yes, sir.
So today we'll stop over here only.